So we have a new Venn diagram here that probably is a more realistic depiction of what's going on in reality. So we have our DV still is salary, and we have our two predictors correlated with one another, and the part of that shared variance is also shared with the DV. So as you can see, the A section is the unique variance in salary that's contributed by years since PhD aside from publications, and then B is the reverse. It's the unique variability in salary that is predicted by number of publications aside from years since PhD. But the C space is that shared variance in the predictors that's also shared with the DV, and so that C space is a little bit troublesome because we don't know who to give it to. It's just kind of sitting there, and we don't want to count the C space twice. So we don't want to, like we had in the previous slide where we would be counting the C space twice. We gave it to both predictors. We gave it to years since PhD, and we gave it to pubs, and we counted it twice. So the good news is that multiple regression solves this issue because we're going to throw both the predictors into the equation. We're going to regress salary on both, and then we're going to see the unique variance that's associated. So we're going to parse out that C part and only look at A and B. And we could not have done that if we just did simple regression twice, if we regress salary on each one separately. So time and publications are correlated higher than I had surmised earlier. So there it is, 0.65, and so we've got to calculate the formula down below. So it's very similar to the one we had before. Let me just talk about notation briefly here. We have the predicted y is equal to our y-intercept, which in this case is the expected value of the DV when all predictors are set to 0. So it's not just one this time, it's all of them. So when all of them are set to 0, what is that DV expected to be? We have the B weight for the BY1.2, and that just means that this is the slope, the expected change in the DV when we increase predictor 1 by 1 unit, in this case years since PhD. So for each year after PhD, what do we expect the change to be in salary, accounting for the number of publications? So that's the cool part, is that these B weights account for the other predictor being in the model. Similarly, we have the BY2.1, and that just means the unique variance that is accounted for in salary by the X2 variable, number of pubs, accounting for the variability explained by the first predictor. Okay, so those are the B weights in the multiple regression case, and then we have X1 and X2 in the equation as well. There you can see them, and those are values of X that we will plug in. So we have an individual, let's say, and we would put his or her year since PhD in the X1 space, and we would put their number of pubs in the X2 space, and we would have the B weights and the constant or the y-intercept, and we would be able to calculate their predicted value of salary. So their predicted salary based on that information. It's so cool. So we'll do more of that in a second here, but that is the conceptual and the visual understanding of shared variance and the unique variance that each of the predictors contribute to the DV.